Okay, we're starting the lesson on 2.4. This is measures of variation. You've probably recognized the word. I'm on page 82 in the textbook. I have, created a set of notes that I shared with you that I'll be writing on. I'll switch over to my document camera in just a second. But the first one that you're very used to, the word range. I mean, we talked about range when we did, when we found the class widths. Remember, the range is the maximum data entry minus the minimum data entry. So we've already used that. It's the same range that we use. StatCrunch will do it. This one's going to be new to you, variance and standard deviation. That one is going to be a little bit different, but I think I may have come up with a pretty reasonable explanation that might help you understand what variance and deviation is. So anyway, let me go ahead and move over here. I tried to adjust my light, and I think I've got like a bright spot over here and now a dark spot over here. But anyway, to find the range of the data, you do exactly what it says. I've got it done right here. You take the biggest number, which is 47, subtract the smallest number, so the range is 10. So remember, variation, another way to explain that is talking about the spread of the data. And doesn't the range fit this, talking about the spread? How far apart? What kind of numbers are we going to be running into? How far apart are these numbers? Well, there's a spread of 10 here. So those are reasonably pretty close together, I guess. I mean, if we're talking about age, 10 years is a pretty close age range. I have friends, that are definitely 10 years older and 10 years younger. So in terms of age, 10 years is not that big of a spread in either direction. But if you're talking about, I don't know, something that has like maybe weight, 10 pounds is a pretty big, jump. I know when I gain or lose 10 pounds, because I'm so short, I'm changing, a pant size with 10 pounds. I mean, my pants no longer fit if I gain 10 pounds. If I lose 10 pounds, I'm, getting to go to a smaller size. So it depends on what it is, whether or not a range of 10 is a big deal or not. Okay, so we know how to do range. Now let's talk about deviation here. Now notice in the definition that was in your book, they said standard deviation. I mean, that was the next thing, variance and standard deviation. So before we get to standard deviation, we're just going to talk about in general what deviation means. Okay, so that's where I'm headed. So give me just a second. I keep doing that stupid formula. That stupid program. Anyway, so the deviation, it says, when they're talking about a deviation, they're talking about what this formula says right here is basically they want to know how far away from the average are you? How far away from the average, okay? So when we're talking about variance, they basically want to know is if you take a whole bunch of differences, it's kind of like the average of differences. That's what it is. So let me run over here. Where am I? This one. Okay. So if we found the mean of this group of data, and you know how to find the mean, you add them all together and you divide by 2. I think that's what I had on this piece of paper. I did. Let me go back over here and show you this. So I found the range. The range was 10, and I calculated the range simply because that belongs to variation. It's a measurement of spread. Now to find the variance and the standard deviation, which also is going to be things you have to compute, you need to know what the average is because the average is part of the formula right here. So you have to know what the mu, remember that's mu, that's the average of the population. So in order to I had to find that, and you know how you do it. You add them all together and you divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 numbers. Don't get that confused with the range. The mu was calculated by finding the sum of the x's and dividing by, since this is mu, we're going to do capital N, And the capital N up here is 10 because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Okay, that's where we get the 10. All right, so you add them all up and divide by 10, I got 41.5. So on this graph over here, on this picture, this drawing that I did, I put a number line because that's what we're talking about. Anytime we're dealing with numbers, we're on a number line, and there's 41.5. It's halfway between 41 and 42. Okay, and then I'm going to go look at the numbers in the data set. Okay, so what I'm talking about is I'm looking at these numbers right here. So I'm looking at 38. I'm particularly looking at 38. Why? I don't know. It was a nice distance away when I made this graph. So I looked at 38, and if I ask you how far away is 38 from the average, okay? Now I have the number negative 3.5 written up here, but most of you would not say negative 3.5. If I said how far away is 38 from 41.5, you'd say it's 3.5, because you go, well, 38's here, so 1, 2, 3.5, it's 3.5 away. Because we are not in a habit of measuring things with negative values. How many times have you pulled out a ruler and found a negative number on it? You haven't. Rulers don't come with negative numbers. Or a measuring tape, or a tape measure. You know, if I'm going to measure my waist, you know, it's not going, my waist measurement may change as I gain and lose weight, but I don't generally give you the measurement of my waist with a negative number. Even if it's changed by getting smaller, I still don't give you the measurement in a negative number. So what variance is, okay, let me back up. Deviation is just how far away is it. Like when you're playing, I think I pulled up, yeah, like when you're playing horseshoes, you know, the idea of horseshoes is to get as close as you can. Well, sometimes you're not gonna, this dude right here, he managed to hit the spike, but these two over here, there would still be a winner even if you didn't hit the spike from these two darker. It looks like the lighter ones are probably one person playing, and then this one right here is the other person playing. If we remove these gold ones, this guy right here, he's a little bit farther away than this one, but you wouldn't give the measurement as a negative number. You would just say, well, it's farther away. There's a greater distance between here and here, and between here and here. You wouldn't matter that one's on the right side, one's on the left side. But when you're on a number line and you have a formula, and the formula tells you that you have to subtract, and that's what we have over here. We have a formula, and the formula is right here. It says to find how far away you are, you have to take the data point, which in this case, if we're talking about 38, and you have to subtract it from the average. Okay, so I have to say 38 minus 41.5. And by mathematics, if I take 38 minus 41.5, that's going to leave me with a negative number. Okay, so and so you're okay, I get it. I know if it ended up being, you know, before 41.5, the difference is a negative number because it didn't quite reach 41.5. It's on the other side. It went beyond 41.5, so it's a positive number. I get it. Okay, well, that's good. But remember, if we're talking about finding the average of the differences, okay, well, what happens when you add a negative 3.5 to a positive 3.5? What happens? You get 0. And that's not really, 0 is not really the sum of these two differences. Because really, shouldn't it be about 7? This one was 3.5 away. This one was 3.5 away, just on the other side. But if we add those two distances away, haven't we accumulated a distance of 7? So that's what's happening when we use this formula that forces us to subtract. We end up with some negative distances, and then we end up with some positive distances, and then when we try to add them together down here, we would end up getting a number that doesn't make any sense when we added all those up. So someone smarter than me came up with a way that we can add the differences without having to worry about the negatives. And so what they do is they take these differences and they square them. Because what happens when you multiply a negative number times a negative number? You get a positive number. And what happens when you multiply a positive number times a positive number? You still get a positive number. So what they're going to do to find out what the average distance is they're going to add up all of these differences squared. Now, why do we square them? Why do we square them? To remove the negatives. So we can add, so that we can add these all up. So we find out how far apart a data entry is from the mean. Remember, this is the average. How far away are we from the average? How far away are we from the average? How far from the average? How far from the average? That's what each one of these things are saying. I was really close to the average. I was far away from the average. I was real far away from the average. I was pretty close to the average. Notice that I don't care whether it's a positive or negative. These right here that are 0.5, they are close to the average. This one's just as close as this one. But because this one's negative, if I added these two together, I would get 0. And I don't want to get 0. I want to add 0.5 and 0.5 and get 1. So the best way that they can do that is square these and then add them up. So this is called the sum of the differences squared. This is the sum right here. I add it all up. What did I add up? The differences squared. Okay, so I added up the differences squared, and then I divided by how many differences squared I had. I got that. That's an average, right? I'm adding something up. I'm dividing by how many I have. So the average of the sum of the differences squared is called, this is sigma. This is the lowercase sigma. Remember, this is uppercase sigma. This is lowercase sigma. Sigma squared, that is called, that number right there is called the population variance. Okay, so, and variance is really just the average of the distances. That's what you need to think about, the average of the distances. Now, the standard deviation is going to be the square root of that number, because really what we want to see, the averages of the differences, that's what we really want. This is not the average of the differences. This is the average of the differences squared. So this is not exactly what we want, but if we squared something, how do we undo squaring something? We square root it. So if we take the square root of this number, then we get this, which is just sigma, and sigma is the standard deviation. And really what the standard deviation is just the average of the differences. Okay? It's kind of the average of those. It's not exactly, because we can't add them together and divide by 10 because we get pluses and minuses. So we cheat and we square them to get rid of the negatives. We add up all those positive numbers and we find the average of those. But that's not the average of the differences either, because we squared them. So now we're unsquaring them to kind of get the average of the differences. And that's what this is, the average of the differences. The standard deviation is the average of the distance. So if we added up all these differences, think of these as horseshoes. This one landed real close. This one landed 3.5 units away, 2.5 units away, 3.5 units away, 5.5 units away, half a unit away. If you added all those differences up and ignored the signs, the average different distance away from the spike was 2.97. So it's about 3. So most horseshoes landed about 3 units away from the spike. That's what that's telling us, okay? And this number right here, sigma squared, this is variance, population variance, and then this is standard deviation for the population. And I will talk more about that in the next video because I feel like I've been talking 100 hours. So I'm going to stop.